If you try to calculate 8 divided by the square root of 2 by hand, you have to divide the number 8 by an infinite decimal, since root 2 is 1.414213 and so on. Performing this division with a decimal that never ends is very difficult and time consuming. But what if we could rewrite this fraction so that we multiply instead of divide? Multiplying 4 by 1.414213 is straightforward to do even without a calculator. This is the problem that rationalization solves. It takes a fraction with an irrational square root on the bottom and rearranges it so that the bottom is a clean whole number. Hi, welcome to My Exam Revision. In our last video, we covered what surds are and how to add, subtract, multiply and divide them. If you don't remember these concepts, please watch that video first. I've linked it in the description below. Today, we will build on those basics to learn how to rationalize the denominator. This lesson is divided into 3 key sections. In the first section, we will learn how to handle simple single-term denominators. In the second section, we will look at denominators with 2 terms and introduce a useful algebraic tool called the conjugate. In the third and final section, we will work through a more complex exam question that has surds on both the top and the bottom.
I've added timestamps in the timeline below, so if you'd like to skip ahead to a particular section, you can do that easily. I've also included detailed notes in the description. If you'd like to go through the steps more carefully in your own time, you can click the link and follow everything step by step.
Now, let's get started. Let me start by defining what rationalizing the denominator means. The denominator is the bottom of a fraction. When a fraction has a square root on the bottom, we call it an irrational denominator. To rationalize it, we want to convert that square root into a rational whole number without changing the actual value of the fraction. Let's look at our first example. Rationalize the denominator of 8 over square root of 2. To solve this, we use the fundamental rule of fractions. Whatever you do to the bottom, you must also do to the top. If we multiply the bottom of a fraction by square root of 2, we are multiplying a square root by itself. Any square root multiplied by itself simplifies to the number inside the root. Therefore, square root of 2 times square root of 2 is simply 2. To keep the fraction balanced, we also multiply the top by square root of 2. This gives us 8 square root of 2. Let's write down our new fraction, 8 square root of 2 over 2. Now, we check if we can simplify further. The whole number 8 on top can be divided by the 2 on the bottom. 8 divided by 2 equals 4. So our fully simplified rationalized answer is 4 square root of 2. This is a much simpler form than our original fraction. Now let's look at a slightly harder example. Rationalize the denominator of 12 over 7 square root of 3. You can pause the video here and try to solve this question yourself. Here we have a coefficient of 7 in front of the square root. A common mistake is to multiply the top and bottom by the entire term, 7 square root of 3. While this still leads to the correct answer, it makes the numbers much larger and increases the chance of a calculation error. Remember, our only goal is to remove the square root. The number 7 is already a rational number. Therefore, we only need to multiply the top and bottom by the root part, which is square root of 3. Let's apply this. We multiply the top and bottom by square root of 3. On the top, 12 times square root of 3 gives 12 square root of 3. On the bottom, we have 7 times square root of 3 times square root of 3. Since square root of 3 times square root of 3 is 3, the bottom becomes 7 times 3 equals 21. Putting this together gives 12 square root of 3 over 21. Now, we check if we can simplify this fraction. If we look at our whole numbers, 12 and 21 both can be divided by 3. 12 divided by 3 is 4 and 21 divided by 3 is 7. This gives us our final fully simplified answer, 4 square root of 3 over 7. This completes our first section. You should now feel comfortable rationalizing single-term denominators. Before we move to the next section, I want to quickly mention something that will help you practice this topic properly. On my website, My Exam Revision, I have created a full worksheet for each topic. It starts with basic foundation questions, then moves on to harder multi-step problems, and finally proper past paper exam style questions. all with step-by-step solutions. I've also built an AI version of myself based on my 14 years of teaching experience in GCSE Maths, A-level Maths and further Maths. You can check the step-by-step solutions, and if you get stuck, you can simply take a photo and upload your working. It will analyze each step, highlight where you went wrong, and even if your final answer is correct, it will still check your method thoroughly. If you're serious about improving your grades, I highly recommend trying it. The link is in the description. Now, let's move on to section 2. We will now discuss how to rationalize denominators that contain two terms. Let's look at this expression, 6 over 2 minus square root of 3. Here, we have a subtraction on the bottom, 2 minus square root of 3. If we try to multiply the bottom by square root of 3 as we did before, we have to expand it across both terms. Square root of 3 times 2 minus square root of 3 equals 2 square root of 3 minus 3. Notice that the square root is still there. Multiplying by the root alone does not work when there are two terms on the bottom. To eliminate the root, we use an algebraic identity called the difference of two squares. A minus b times a plus b equals a squared minus b squared. When we multiply these two expressions, the middle terms cancel out, leaving us with only squared terms. If a or b are square roots, squaring them turns them into rational whole numbers. The expression with the opposite sign, a plus b, is called the conjugate of a minus b. To rationalize any two-term denominator, we multiply the top and bottom of the fraction by its conjugate. Let's apply this. The denominator is 2 minus square root of 3. Its conjugate is the same expression but with the sign changed. 2 plus square root of 3. We multiply the top and bottom by 2 plus square root of 3. Let's calculate the new denominator first. 2 minus square root of 3 times 2 plus square root of 3. Using our identity, this simplifies to the first term squared minus the second term squared. 2 squared is 4 and square root of 3 squared is 3. 4 minus 3 equals 1. The denominator simplifies to the number 1. Now let's calculate the top of our fraction. We multiply 6 by the conjugate. 6 times 2 plus square root of 3. We expand the 6 across. 6 times 2 is 12 and 6 times square root of 3 is 6 square root of 3. This gives 12 plus 6 square root of 3. Putting the top and bottom back together, we get 12 plus 6 square root of 3 over 1, which simplifies to 12 plus 6 square root of 3. Let's look at another example where the surd comes first. Rationalize the denominator of 16 over square root of 11 minus 3. You can pause the video here and try to solve this question yourself. Our denominator is square root of 11 minus 3, so the conjugate is square root of 11 plus 3. We multiply the top and bottom by square root of 11 plus 3. Here is a useful tip for your exams. Do not expand the top immediately. Keep it factorized first. 16 times square root of 11 plus 3. Often the number on the bottom will divide nicely into the number outside, which makes simplifying much easier. Let's work out our denominator. Square root of 11 minus 3 times square root of 11 plus 3. This is our difference of two squares. The square of square root of 11 is 11 and the square of 3 is 9. 11 minus 9 equals 2. Our denominator is 2. Let's write our fraction out. 16 times square root of 11 plus 3 over 2. Because we kept the top factorized, we can simplify 16 divided by 2, which is 8. This leaves us with 8 times square root of 11 plus 3. Now we expand to get our final answer. 8 square root of 11 plus 24. Keeping the numerator factorized makes your calculations much cleaner. We are now ready to look at a more challenging exam-style question. This represents the most advanced type of rationalization question you will see, featuring two terms on both the top and the bottom. Rationalize the denominator of square root of 2 minus 2 over 3 square root of 2 plus 4. You can pause the video here and try to solve this question yourself. Now, let's solve it. The steps are exactly the same as before. We focus on the bottom first. The denominator is 3 square root of 2 plus 4. Its conjugate is 3 square root of 2 minus 4. We multiply the top and bottom by 3 square root of 2 minus 4. Let me calculate the denominator first. 3 square root of 2 plus 4 times 3 square root of 2 minus 4. Using the difference of two squares, this is our first term squared minus our second term squared. 3 square root of 2 squared minus 4 squared. When squaring 3 square root of 2, we square the 3 and we square the square root of 2. 3 squared is 9 and square root of 2 squared is 2. 9 times 2 is 18. So 3 square root of 2 squared equals 18. 4 squared is 16. This gives 18 minus 16 equals 2. Our denominator is 2. Now let me calculate our numerator by expanding. Square root of 2 minus 2 times 3 square root of 2 minus 4. We will expand this using the FOIL method. First, outer, inner, last. First, square root of 2 times 3 square root of 2 equals 3 times 2, which is 6. Outer, square root of 2 times minus 4 is minus 4 square root of 2. Inner minus 2 times 3 square root of 2 is minus 6 square root of 2. Last, minus 2 times minus 4 is plus 8. Let's write this expanded expression down. 6 minus 4 square root of 2 minus 6 square root of 2 plus 8. Now we collect like terms. First, add the integers. 6 plus 8 is 14. Next, combine the surds. Minus 4 square root of 2 minus 6 square root of 2 is minus 10 square root of 2. This leaves our numerator as 14 minus 10 square root of 2. Now we combine our numerator and denominator. 14 minus 10 square root of 2 over 2. To find the final answer, we divide both terms in the numerator by the 2 on the bottom. 14 divided by 2 is 7 and minus 10 divided by 2 is minus 5. This gives our final simplified answer, 7 minus 5 square root of 2. By following these systematic steps, you can confidently solve any complex rationalization question on your exam. I hope you enjoyed this video. If you did, please give it a like and subscribe to our channel. We will be bringing out more educational content like this, so make sure to follow the channel. Also, don't forget to try the questions on the worksheet linked in the description. Thank you for watching.